Look up on a clear night, and the sky feels like a vast, flat canvas speckled with paint. Some dots are blindingly bright, while others barely register against the black background. It makes you wonder, is a brilliant star actually a massive inferno right in our cosmic backyard, or is it just an optical illusion? This animation illustrates a simple trick of perspective. A tiny street lamp just a few feet from your face will easily blind you, while a massive stadium floodlight 3 miles away looks like a dim flicker. Ancient astronomers fell for this exact trick. In the 2nd century BC, the Greek astronomer Hipparchus categorized the stars he could see on a scale from 1 to 6, based entirely on their apparent magnitude, meaning, quite simply, how bright they looked from Earth. Our own sun is the ultimate example of this effect. It holds an apparent magnitude of -26.8, dominating our sky. But as these dark sunspots show, it is just a tangible, physical star that happens to be sitting right next to us. To figure out a star's actual power, its true intrinsic brightness, we have to know precisely how far away it is. Without a physical measuring tape stretching out into the void, we are stuck viewing the universe as a flat, two-dimensional projection. Try this. Extend your arm, hold up your thumb, and close your left eye. Now open it and close your right. Your thumb appears to jump back and forth against the background. You haven't moved your hand. That shifting left and right is called parallax, the apparent change in position of an object viewed from two different locations. Astronomers realized they could use this exact geometry to measure the stars. Human eyes are too close together to see a cosmic shift. As this diagram shows, they log a star's position in January, wait 6 months for Earth to orbit to the opposite side of the Sun, and measure it again in July. This angular shift, marked as theta, defines a parsec, parallax of 1 arcsecond. By tracing lines and solving for angles, humanity calculated the actual distance to the stars without ever leaving the ground. Once we know those distances in parsecs, the flat ceiling of the night sky shatters into 3 dimensions. This spatial map visualizes a thought experiment used to calculate absolute magnitude and luminosity, the total energy a star radiates per second. Imagine taking every star in the sky and lining them all up exactly 10 parsecs away from Earth. From our normal vantage point here on the ground, our sun dominates, while Sirius A, the brightest star in the night sky, registers as a distant second. But at that uniform 10 parsec baseline, the sun shrinks to a faint speck. Sirius A is exposed as a massive powerhouse, radiating 25 times more energy than our own star. Because standard kilometers and kilograms are useless at this massive scale, astrophysicists assign our sun a baseline value of exactly 1. Everything else in the cosmos is measured in solar mass and solar radius. The light that happens to hit Earth is just a geographic accident. A stellar object's actual power is measured by the total energy it burns in the dark. Look at the night sky with these new measurements, and you start to see depth instead of a flat painting. A spectacularly bright object like Jupiter is a deceptive neighbor. It produces no fire of its own, merely reflecting the sun's light. Meanwhile, a tiny, faint speck hiding in the constellation Scorpius is Antares, a supergiant sitting 150 parsecs away, with a radius 700 times larger than our sun. Calculating these exact masses enabled astrophysicists like S. Chandrasekhar to look even further into the life cycle of stars, proving that dying cores will collapse under their own gravity to form dense white dwarfs. The cosmos operates on a scale that completely outstrips human comprehension. We are talking about stellar lifespans measured in billions of years and distances spanning tens of trillions of kilometers. Yet, working with simple angles, glass lenses, and mathematics, a species anchored to a single rock with a lifespan of less than a century managed to trace the shape of the infinite. When you look up tonight, the scattered points of light resolve into a deep, three-dimensional map, the universe's greatest solved mystery.